to my YouTube channel again. So today we are seeing physics. Like I said, my last video emphasized the dimension of fundamental unit or basic unit. So today we are going to look at dimensions of derived unit. So we are going to take some of these units or quantities, so we find their dimensions. In our next video, we are going to look at how we can solve the complicated questions under these dimensions. So if you are new here, kindly help me to subscribe, and if you've done that already, help me to like and share this video to your friends. So like I said, there's no way we can get dimension of derived quantities if the dimensions of fundamental quantities or basic quantities are not known. So one of these quantities that is derived is number one, area. Area is a derived quantity, and to find the dimension of this area, we need to split it with its formula. As we know that derived quantities of derived units are derived from the fundamental based on the particular formula that connects the fundamental or basic quantities. So we know that area is equal to length times breadth, that is L times L. So we want to transform this to dimensional. So the dimension of length, as we discussed in our last class, we said the length has the unit of L, which is the dimension of L, and our breadth is also talking about distance, which is also L. So we can now say the dimension of area is L times L, and this will be L squared. So L squared is the dimension of area. Another one we are going to look at is volume. So volume is length times breadth times height. And if you transform this to dimension, we are going to have L is length, which is the dimension. So the dimension of breadth, since it's also measure distance, this one will also be L times L, which is height. It's also talking about distance. So all this together, if you multiply this, we are going to have L cubed. Therefore, the dimension for volume is L cubed. So another one we want to look at is velocity. Velocity has the formula displacement all over time. So what is the dimension for displacement? This one will be L, since it's talking of distance, over time. The dimension for time is t. So this can also be written as Lt by 1. So the dimension of velocity is Lt by 1. Another dimension we can also talk of is acceleration. Acceleration is change in velocity with respect to time. So which is velocity over time. So the dimension for velocity is Lt by 1 all over time, which is t. That is the dimension of time is t. And this can be written as Lt by, when this comes up, 2. So the dimension for acceleration is Lt by 2. So another thing we want to look at now, let's look at the dimension of force. The dimension of force, or the formula for force, is given as mass times acceleration. So if force is mass times acceleration, and we know that the dimension of acceleration is Lt by 2, and the dimension for mass is given as m times Lt by 2, and this will be equal to m LT/2. So this is dimension for force. We can also work for work, dimension for work or work done. So we know work is done when there is a force with a particular distance covered. That is force times distance. Force times distance. So this formula for work done. So to find the dimension of work, so we are going to put or insert the dimension for force. And the dimension for force we said is mL/2. So we are going to have mL/2 times distance. The dimension for distance is L. So this will give us M, and L times L we have S squared then T/2. So this is dimension for work done. So let's look at another one again. I want to look at power. Let's look at power. As we know that power is equal to work done over time. So if power is work done over time, it means if this is our work done or the dimension for work done, we can easily split it here, and we are going to have a MS² T/2 all over time. So this can also be written as MS². So when this comes here to jump this, we are going to have a T/3. So this is the dimension for power. So we can also have dimension for density. So, and we know that density by formula is mass all over volume. So the dimension for mass is M, and the dimension for /volume is L³, that is length times breadth times side, which is L³. So this can be written as mL/3. So this is the dimension for density. With this method, we can find the dimension for other quantities that are derived quantities, provided we know their formula. So we can also use dimension to find the units of other quantities that are not known. So in our next class, we are going to drop a video on that, which we are going to solve questions that relate to more questions of dimensions. So if you are new here, like I said, please help me to subscribe. You can also follow me on the YouTube, or you follow me on TikTok. So the link above is available to take you to the direction. Thank you so much. I love you all.